Yeah, morning everyone. So myself, I'm Vijay. I hold 13 plus years of experience, which includes 6 plus years of experience in Hadoop and Spark environment. Currently working with PySpark, Spark with Python implementation. So before I start, can anyone please confirm whether my voice is clear and audible? Yeah, can anyone please confirm whether my voice is audible or not? Whether my screen is visible or not? Yeah, fine. Yeah, fine. Thank you. Yeah, I got enough confirmations. One second. Yeah, as part of today's demo, just I'm going to cover the following things. What is big data? First one. What is big data? Why Hadoop? Already we have got many technologies available in the market. Why again Hadoop? And drawbacks of drawbacks. What are the various drawbacks of databases as compared to Hadoop? Drawbacks of databases. Hadoop advantages. Hadoop advantages. Hadoop. Yeah. Yeah. One second. Hadoop components. Okay. Hadoop job market. Yeah. Yeah, one second. What is big data? Why Hadoop? Drawbacks of databases? One second. Let me open this. Okay, fine. So, yeah, what is big data? Data generation and landscape, data sources and types, big data characteristics, big data tools, challenges, applications, why Hadoop, drawbacks of databases. One second. Hadoop advantages, Hadoop architecture, Hadoop ecosystem tools, and Hadoop job market. Trends and Hadoop trends and job market. Fine. Fine. What is big data? Now, observe. What is big data? So today, if you see like data generating, see data generating in the form of KBs of data, MBs of data, GBs, terabytes, petabytes, exabytes, zettabytes, etabytes. So if you say huge data is getting generated, everywhere you see huge data is getting generated. For example, not see how the data is getting generated. See how many tweets, how many tweets in 60 seconds, how many status updates, how many instant messages, how many Google searches, how many emails are sent in a second, in a minute, how many, what is the TBs of data is created, and how many mobile users. Okay, so now, so if we say that what is big data, what is big data? Now, if we say what is the data storage units currently, how the data is getting stored, like you are going to see like KBs of data, MBs of data, GBs of data, gigabytes, terabytes, petabytes, exabytes, zettabytes, terabytes, so on. So in this from TB onwards, we are going to say it as big data. From TB onwards, we are going to say it as big data, huge data. So you should have seen KBs of data, MBs of data, GBs of data, even TBs of data. But do you think that petabytes of data, is it getting generated? Petabytes of data, is it getting generated in the current real world? If so, examples of petabytes of data generation, petabytes or exabytes of data generation. Can you please give me the examples of petabytes of data generations? I want the sessions to be interactive. So yeah, fine. You can speak out. Okay, I'm just unmuting all of you. Okay, okay.
The Forex market, Wall Street,
Petabytes of data generation or exabytes of data generation. Can you please give examples of petabytes of data generation today?
the share
Yeah,
market,
yeah. So I can give many examples. Now today, if you see, most of the applications are generating data in petabytes. For example, if you take any banking sector, take any bank like SBI or HDFC. Within the city, you see hundreds of branches. Within the entire state, you are going to see thousands of branches for that bank. Within the entire country, lakhs of branches for a particular bank like SBI or HDFC. So lakhs of branches, again within each branch, millions of lakhs of customers, each customer making multiple transactions. Each and every transactions need to be stored per hour, per day, or per week, per month, or per year. Each and every transaction, huge data getting generated. Okay, forget about it. Everyone are aware about social media like Facebook. Facebook has got users not only within the country, entire world, like millions and trillions of users for Facebook. What is the data generated by Facebook in a minute? How many posts and videos are getting circulated, and what is the data generated by Facebook in a minute? Huge data. Okay, not only like Facebook, today we see every application generating data, every application generating data in petabytes. For example, if I take a 1 minute transaction, if I take 1 minute of transaction, in 1 minute, how many FB posts, how many FB posts, Facebook posts, and what is the data generated by Facebook in a minute? Twitter tweets. Okay, everyone, just in a minute, how many Google queries, what is the data generated by Google in a minute? YouTube videos upload, YouTube videos upload. Today everyone creating their own videos and uploading in the YouTube. What is the storage, what is the data generated by YouTube in a minute? And if you take millions and trillions of users are using email or Gmail messages, email messages, what is the data generated by this? And just now I was talking about bank transactions. I was talking about bank transactions. telecom transactions. And if you see like e-commerce websites like Amazon, Flipkart, so everywhere you see huge data is getting generated, huge data getting generated everywhere. So data is increasing enormously. Even we need to have some proper storage systems for storing and processing the data. Okay. So Facebook on an average generating more than 350 petabytes per month on an average. Google generating more than 450 petabytes per month on an average. Okay. So 450 petabytes means 1 petabyte equal to 1024 TBs. Already 1 TB is a large storage unit, but 450 petabytes means 450 into 1024 TBs. That is what the data generated by Google and an average in a month. So in this way, every application, if you're taking every application generating huge data, every application is going to generate huge data in petabytes of data generation. Okay. Now, if I discuss about the data generation, how the data is getting generated, see, observe. If I take how the data is getting generated from the last 50 years, think this is the data which got generated from the last 50 years. This is the entire data in the real world which got generated from the last 50 years, from 1970 to 2020. If we compare last 10 years of data with the previous 40 years, this is what from the past 50 years. Observe 1970 to 2010, 40 years. Think this here. Only 20% of data got generated, but especially 80% of the data what you are seeing currently, everything got generated from the last 10 years. Last 10 to 15 years, huge data generation you see. Previously, if you see in 1990s, the storage, what were the storage systems? Like floppy disk you have got, size 1.44 MB used to carry floppy disks, or CDs like MB 700 MB, or DVDs. Now you have got USB pen drives. So today if you see, even GBs of data is not sufficient. Today if you see that internal storage and external storage in your mobile phones, in the coming days you are going to see TBs of data also within the mobiles, not sufficient. So why huge data generation? Can anyone say why this huge data is getting generated? What is the reasons for this huge data generation, especially in the last 8 to 10 years? Can anyone say the reasons for the huge data generations?
Process data fast.
Mainly 3 reasons I can say: because of usage of technology, because of usage of internet, or because of usage of internet, and because of usage of smartphones. So huge data generation you see lost, especially from the last 10 years to 15 years, because of usage of technology, usage of internet, usage of smartphones. Today if you see everything through online, online exams, online shopping, online banking, online education, e-learning, okay, online communication, audio video chattings, online, everything through online. Smartphones, because of usage of smartphones, because of usage of technology, huge data is getting generated. Okay, what are the main sources of this data? What are the main sources? Mainly 3 sources I can say, mainly 3 sources of data from where this data is getting generated. Like social data, I can like social data, machine data, and transactional data. What is that? Social data, machine data, and transactional data. What is social data? The data which got generated from social websites like Facebook, Twitter, all this. Machine data means the name itself saying, for example, whenever you go to a shopping mall, for the items you purchase, you get a bill generated. So for the items you, okay, Means the data which got generated by reading or scanning the barcodes, RFID chips, all this. Such kind of data we call it as machine data. Transactional data, day-to-day transactions, bank transactions, telecom transactions. So all these are the various sources from where this data is getting. Mainly, these are the main three sources like social data, machine data, and transactional data from where the data is getting generated. And this data is going to occupy three forms, mainly three types. Three types or three forms, I can say. Structured data, like structured data, semi-structured data, and unstructured data. Structured data, and semi-structured data, and unstructured data. Okay. Structured data means data which is arranged in organized in the form of rows and columns in a structured format, like Excel sheets, database tables. All this comes as structured form. Semi-structured data, data which is not fully structured, which is not fully unstructured. Examples like XML files, JSON files, all this comes as semi-structured. Unstructured data, nothing but articles. You see these articles or chart messages, articles, images, videos, all this comes as unstructured. But today if you see most of the data whatever you are seeing is in the form of unstructured format. Current databases, whatever databases we have got, can handle only structured data. They cannot handle unstructured or semi-structured kind of data. But we need to have a technology where it can handle, which can handle any data. It can handling, or it can store, or it can process any kind of data. So Hadoop is such a kind of framework where it is going to store, it can handle any type, any varieties of data, structured, semi-structured, unstructured kind of data. So like if I come back, we have got databases like see this, we have got databases. Oracle, DB2, MySQL, DB2, all this they are used, etc. They are used for OLTP, online transactional processing. They are used for what? OLTP, online transactional processing, for day-to-day activities. They can handle some GBs of data. We have got some specialized databases available in the market. Specialized databases like Teradata, Netija, Vertica. All these are specialized databases used for data warehouse purpose. These are used for DWH, data warehouse, for OLAP, online analytical processing. So these databases, they can handle TBs of data, but to handle petabytes of data or exabytes of data higher than that, so we doesn't have proper tools. But to overcome all these storage level issues, we have got a framework called Hadoop. Hadoop is meant for two things. Observe this. Hadoop is going to provide two types of services. Hadoop mainly meant for two things. Observe. It is meant for storage or processing. It is meant for storage and processing. It is so if you take any technology, it performs either storage or processing. If you take C or C++ or Java or these things, they are meant for processing. If you take any technology like Oracle, MySQL, or DB2, SQL Server, all this meant for what? Storage. Either storing the data or processing the data. But Hadoop is meant for both storage plus processing. And I've got some couple of queries here. when Hadoop is able to store and process the data, and what is the necessity of this processing and storage technologies which are available currently? Do you think when Hadoop is in the market, do you think this will go away from the market? What is your answer? Hadoop, I'm saying like Hadoop is meant for storage and processing. So when Hadoop is able to store and process the data, then what is the necessity of the current storage and processing technologies in the market?
I think Hadoop is new in the market, so it will take time to overtake all those things, all those
Okay.
technologies.
Okay. So here you need to understand two things. One, Hadoop is meant for huge data. Hadoop is meant for batch processing. Hadoop is meant for batch applications. Hadoop is not for OLTP. Hadoop is not for OLTP, online transactional processing. For a single record or two records, three records, you won't go for. You're making a transaction, no need of Hadoop for that. Single record or two records, no need of Hadoop. Hadoop is bad for small data. Hadoop is good for huge data, millions and trillions of records. Huge data in TBs or petabytes of data storage and processing. Go for Hadoop. For small data, okay, you're storing or processing that. And one more thing, for this OLTP, we are going with anyhow with this databases. Hadoop is not for OLTP. Hadoop is for batch application, for batch processing. And for processing point of view, huge data processing, not for what MBs of data, KBs of data, you are not going to go for a Hadoop for processing. If you take a processing technologies like Java in the real time, you go for Eclipse IDE. For Eclipse, what is the data you provide? KBs, MBs, GBs, terabytes, petabytes. If you are giving data in TBs or petabytes, taking huge time. Okay, the IDs I'm talking about, this IDs, it sometimes they won't even start. So like Hadoop is Hadoop is a kind of framework which can store huge data, unlimited data, and process that huge data in quick time. So storing huge data and processing that huge data in quick time. Thus you go for Hadoop. When to go for Hadoop is huge data, millions of records are huge data, and processing that records in quick time, you go for Hadoop. And any of for the small data, you can just go with the processing technologies. And mainly Hadoop is meant for batch processing. Okay, there are two types of applications I'm saying. Like, one second, I'll come back to this. There are two types of applications. Two types of applications. Online applications, online applications, online processing, otherwise online processing, and batch applications or batch processing. Okay, online applications are batch applications. Examples of online applications. What do you mean by online applications or online processing? Online applications means user interactive applications. User interactive applications, we call it as online applications. User interactive. This is user interactive. This is user is nowhere required here. User interactive applications, we call it as online applications. User gives the input here. Batch applications, user nowhere required. Example of online applications.
Banking.
Yeah, booking a movie ticket, or booking any railway ticket, or making a transaction, credit card transaction, making an online transaction, everything are online applications, online processing. Okay, example of batch application. For example of batch application means, for example, railway booking PNR status. Today you have got a waiting list of 170. After 1 hour it is 140. Evening it is 100. tomorrow 50, later finally you got confirmed. Means, is user involvement required there? Is user involvement required? Does he any input he need to give? No. User non-interactive applications. See, most of this finance sector, they're mostly that batch applications like banking, insurance, trading. All this 80% of the operations are background applications. They're batch applications. Examples of online means money depositing, with depositing amount or money, or withdrawing it, or ticket booking, or canceling, or updating. All these are online applications. If you want to cancel, if you want to update, if you want to book a ticket, or if you want to deposit, withdrawal, all these are online applications. Batch applications examples, mainly batch applications examples. Here online application means single transactions, credit card transaction, credit card transactions. But batch applications means examples of batch applications: bank statements generation, bank statement generations, credit card bill generations, credit card bill generations, mobile bill generations. Means credit card bill generations means for millions of customers, not for a particular customer. Online application means a single customer or two customers are involved, but credit card bill generations for all the customers. Batch. For credit card bill generation, is user involvement required? Bank statement generation. For bank statements generation, is user involvement required? No way. Mobile bill generation, PNR waiting status generation. For all this, user involvement no way required. Bank statement generation, credit card or mobile bill PNR status. These are batch applications. Batch, all this, where millions and trillions of that is statements we need to generate. Which has got more load, online or batch? I want the sessions to be interactive. Whether your answers are correct or wrong, please try to interact. Which has got more load?
Batch.
Batch has got more load, because you are generating statement for what? Lakhs and millions of customers. Online means you are just making a single transaction. Okay. I said Hadoop can perform only batch processing. Hadoop can perform only batch processing. But Hadoop cannot perform. Databases can perform OLTP, online transactional processing, online processing. But Hadoop to perform online processing, Hadoop to perform online or OLTP processing, Hadoop today, if you see Hadoop integrated with NoSQL databases, Hadoop plus NoSQL databases combinedly together can perform batch and online processing. Batch and online both can be performed. Hadoop integration with NoSQL databases can perform both batch and online processing. Today, NoSQL databases has got great demand. If you observe, as compared to the SQL databases, NoSQL databases has got great demand in the today's market. For example, observe. As a Hadoop developer, you need to have the idea about at least one NoSQL database. Mandatory. Like if you take e-commerce websites like Facebook, if you see this Facebook, LinkedIn, Yahoo, Amazon, all the top 100 websites, they won't use RDBMS, they won't use databases. For example, if you take Facebook, what is the data generated by Facebook? Like 3 trillion transactions, 3 trillion transactions per second. Means per minute you see, per hour you see, what is the data generation? So here, databases like Oracle are not used. 3 trillion transactions per second. Here, databases like Oracle are not used. If 1 lakh records are attacking a Oracle server, if 1 lakh records are attacking a Oracle server, server will be hanged out. See, for example, previously, now currently, if I say this currently, Facebook it is generating nearly 80 TB per day. On an average, it is generating 80 TB. Or this total capacity or lifetime capacity of Oracle. If you take Oracle can store what, how much, up to what extent it can store. Total capacity or lifetime capacity of Oracle, 50 TB. Beyond that, it cannot. Oracle has got some limitation, 50 TBs of data. Later, behind that, it cannot. Facebook per day it is generating 80 TB. One day data it cannot store data. So the transactional load, see the transactional load 80 TB. One day data cannot be stored by Oracle. Lifetime capacity of Oracle totally. So for all this, we go for NoSQL databases, next generation databases. Even for example, after 2021 or 22, see this RDB mess. See the next generation OLTP will be the NoSQL databases, schemaless behavior. For SQL, like SQL databases like Oracle, schema is required. For first record to the last record, same schema need to be maintained. But in the case of NoSQL, schemaless behavior means my first record can go with 3 fields, second record with 5 fields, third record with 7 fields, fourth record with 10 fields. Schemaless behavior. We have got many NoSQL databases in the market. We have got many NoSQL databases in the market, like famous NoSQL databases like Cassandra, HBase, MongoDB. These are the famous NoSQL databases. But not only this Cassandra, HBase, MongoDB, we have got many NoSQL databases like CouchDB is there, React is there, Peanut is there, Neo4j. Many NoSQL databases. Famous one are Cassandra, HBase, and MongoDB. HBase especially designed for Hadoop. HBase is a NoSQL database. It works only for Hadoop environment, not for any other. Cassandra and MongoDB for open applications, for any, not only for Hadoop, for any other applications. Okay, fine. So Hadoop as an integration with NoSQL databases can perform both online and batch processing. So for example, if you see that if e-commerce websites like Flipkart generating nearly 15 TB per day, but if you take that example of SBI, it is generating 15 TB per year. So for NoSQL databases, for online processing, see this NoSQL databases playing a vital role today. So just I'll come back where so Hadoop is meant for both storage and processing, and for storing the data and for processing the data. Fine.
I have a question here.
Go ahead.
Is the bash process, the bash application is the historical data
Batch application?
contains historical data?
Yeah, batch applications consist of historical data.
Thank you.
Yes. Okay, so here I got one more query. For storing the data, does Hadoop use any databases internally for storing it? For storing the data, does Hadoop use any databases? No, Hadoop doesn't use any databases. Databases has got some drawbacks, lot of drawbacks. So despite of the drawbacks, Hadoop doesn't go with any databases for storing its data. I will just brief you about, I will list out the drawbacks of databases. So Hadoop, so despite of the databases, Hadoop going with a kind of file system called as Hadoop distributed file system. Hadoop distributed file system. And for processing, it is going with the execution model called as MapReduce. For storage, HDFS, and for processing, MapReduce. Okay. Storage, HDFS, and for processing, MapReduce. Okay. So this is what Hadoop providing two services, storage and processing. It is meant for both storing in data and processing the data. For storage, we go for HDFS, and for processing, MapReduce. So hope you understood what is big data, why, how the data is getting generated, huge data, and why Hadoop, and what Hadoop is going to perform like storage and processing, and MapReduce. I'll discuss these things, why databases, drawbacks of databases. What are the drawbacks of databases? I'll discuss in the coming session. And before that, let me discuss about Hadoop advantages. Hadoop advantages. Okay, coming back to this. Okay, now if you see this. Sources of data generation, from where this data is getting generated, from social media, from sensors, mobile phones, GPS, purchases, World Wide Web, emails, media and streaming, and healthcare and IoT. So big data, so huge data, from where you are going to get the data, from some Google, Facebook, Instagram, YouTube, all this, Pinterest. Types of data I was just discussing, like structured, semi-structured, and unstructured. See, for examples of unstructured data types: text files, documents, server, website and application logs, sensor data, images, video files, audio files, emails, social media data. All these are unstructured data types. So today, like most of the time, data is in unstructured format. Whatever data you got generated, 80% of the data is whatever got generated from the last 10 years or 15 years. Most of that, it's going to occupy unstructured format. So Hadoop is such a kind of framework which can handle all varieties of data, structured, semi-structured, and unstructured. Okay, fine. One second. So from different databases, data warehouses, from various things, you are just going to load the data into this social media, Excel files, CSV files, and you are going to bringing to one place, storing it and processing it. On the processed results, you are just going to perform some kind of analysis and reports. So data like structured, unstructured, geographic data, real-time data, natural language data, time series data, event data, network data, linked data, graph data. Linked data is nothing but graph data. Real-time data. See, real-time data means, okay, or you can see like streaming data, data which keeps on streaming, data which, what do you mean by streaming data? Streaming data means the data which keeps on generating. The data which keeps on generating, we call it as streaming data. So like even today, like Hadoop is going to see, we have got some components like Flume Kafka. We've got some components like Flume Kafka, where we can see using this Flume and Kafka capturing streaming data. Streaming data means data which keeps on generating, data which keeps on incrementing. For example, if you are downloading any file, it is a static. If you see like morning, it will be like 2 GB. Even if you see in the evening, it will be 2 GB. Tomorrow, if you see, it will be 2 GB, a downloaded file. But if you see a file, streaming file, for example, if you take a CCTV or webcam, if it's generating, keeps on generating, morning 2 GB, afternoon 4 GB, evening 8 GB, next day like 20 GB. Generating events. Characteristics of big data, mainly 3 V's: volume, variety, and velocity. Means volume, 3 V's we say, 3 V's: volume, variety, and velocity. The amount of data from different sources. Variety means varieties of sources, variety of structured, semi-structured, unstructured types. Velocity, the speed at which the data is generating. Veracity, the degree to which the big data can be trusted. One second. The business value of the data collected. The ways in which the big data can be used and formatted. Variability, value, and veracity. Mainly like volume, variety, and velocity. 3 V's we say mainly. Here, amount of data from different sources, varieties of data, and speed at which the data is getting generated. For example, data is at rest. This is velocity, means data is in motion. Variety means data in different forms like structured, unstructured, semi-structured. Veracity, data in doubt or data in limbo, data in uncertain format. So these are what this Hadoop can handle and can audible to everyone. Is my voice audible to everyone? Can anyone please confirm?
Yes, sir. Audible now.
Fine. Yes, there was a power cut. I was unable to access the data. Fine. Okay. So big data tools. We have got many big data tools. This Hadoop, big data tools like Hadoop, NoSQL database, Spark for real-time processing, Kafka messaging system like Kafka. Kafka is a messaging system and it is used like a messenger and streaming and messaging. It used for both streaming and messaging. Fine. And for data warehousing, we have got a component like Hive component. It's for kind of data warehouse or kind of an environment. And for data analysis, Tableau. Fine. Okay. So now let me discuss about these advantages of Hadoop. One second, I'll come back. Advantages of Hadoop. Hadoop advantages. So before I discuss about Hadoop advantages, let me just I give an overview about this architecture of Hadoop, so that from that we can extract the Hadoop advantages. So fine. Now observe this. Hadoop follows master-slave architecture. Hadoop doesn't follow client-server. It's not a client-server. It's not a request-response architecture. It's a master-slave architecture. Single master, multiple slaves. Single master and multiple slaves. Is what slaves. Slave 1, slave 2, slave, and n number of slaves. So this is what master node. These are what slave nodes. Master node and slave nodes. Okay. Now Hadoop in the end, if I take Hadoop data is stored by the slaves, data is processed by the stored by the slaves, and data is processed by the slaves. Slave nodes we call it as data nodes. Slave nodes we are going to call it as data nodes. And master node like name node. Okay. Data nodes, why data nodes means data is stored by the slaves, data is processed by the slaves. In Hadoop, who is going to store the data? Data stored by the slaves and data processed by the slaves. That's what we call as data nodes. For example, if I'm taking f1.txt, think that it is a 4 TB size. The size of this file is 4 TB. Think that your each slave capacity 1 TB, hard disk capacity 1 TB, 1 TB. This 4 TB file, can it fit into any of the slave? Not possible. 4 TB file, can it fit into any slave? Not possible. Then Hadoop is able to store the data. How Hadoop is able to accommodate the data? Is my voice clear or not? Can anyone please confirm once again? It's breaking. Voice breaking. 1 second. 1 second. Yeah. Yeah, fine. Yeah, Hadoop is following like master slave architecture. It won't follow like client server architecture. Yeah, single master and multiple slaves. So if I got a file of 4 TB, a 4 TB cannot fit into any of the slaves. So in Hadoop, how exactly data is stored and how exactly data is processed means in Hadoop, how it is able to accommodate huge data files. Data objects means the data is divided into smaller blocks. The data is divided into smaller blocks or chunks, fixed value chunks called blocks. It is divided into blocks. Each block is stored across a slave. Each block is stored across a slave. Means data is going to be splitted into smaller parts called blocks. The blocks are distributed across multiple slave machines. Means data is stored across multiple machines. Multiple slave machines running parallelly, storing and processing the data parallelly. Multiple slaves storing the data and multiple slaves processing the data of a particular file. So that's why huge speed, you are going to see huge speed in Hadoop. Understanding everyone. Data getting splitted into multiple parts, distributed across. That's why we say Hadoop distributed file system. Data gets distributed across multiple slaves and processed by multiple slaves parallelly. Fine.
One question here.
Yes.
What happens if any one of the slave fails? Any issues
Yeah.
come up? Then how?
Yeah. 1 second. Yes. I'll come back to your query. Just give me. Before that, let me just discuss one thing. Fine. I'll come back to your query. So here, this entire thing we call it as a cluster. This entire thing we are going to say it as a cluster. Cluster means a group of CPUs connected in a network. Group of CPUs means nodes we say. CPUs means nodes connected in a network. We have got two types of nodes, master node and slave node. Master node or slave node. Master node or we will call it as like name node. Slave node or data node. Okay. So here, okay, responsibilities. So if data is stored by all the data is stored by the slaves and data is processed by the slaves, then what master node is doing? What is master node responsibilities? Master node responsibilities. If I discuss master node responsibility, first one, task assignment. Task assignment. So this master is going to assign task. T1 task to slave 1, T2 task, T3 task. Means it is going to assign tasks to the slaves. Load balancing. Load balancing. See, load balancing means This is assigning equal task to all the slaves, so not burdening a particular. And third is what? Fault tolerance. Fault tolerance. What is fault tolerance? Just now you asked a query. So if multiple tasks are executed by multiple slaves parallelly, see, in S1 slave 1 10 lakh records, in slave 2 10 lakh records, in slave multiple slaves 10 lakh records are stored, means data is distributed across multiple slaves, means this executing this 10 lakh records is nothing but the task 1, executing this 10 lakh records is nothing but a task T2. When multiple tasks are executed by multiple slaves parallelly as they are machines, so during this process suddenly if any slave think this slave is down, during this process if any slave goes down, then the task of this slave is going to be assigned to any of the available slaves by the master node. This process we call it as fault tolerance mechanism. Fault tolerance mechanism. Just now you asked a query, if during the processing if any slave goes down, so means here two things you need to observe. Your data is going to be stored across multiple slaves, means huge storage is possible, and your job is divided into tasks, and each task is given to one slave, means job divided into tasks, and tasks are executed parallelly for performing. If any slave goes down, then the task of that slave is going to be assigned to any of the available slaves immediately. By whom? Master node. This process we called as fault tolerance, but just I have given an overview only. Internally in the architecture, Hadoop architecture, I'm going to brief you about this fault tolerance, everything. So fault tolerance means multiple tasks, while executing multiple tasks by multiple slaves, suddenly if any slave goes down, then the task of that slave is assigned to any of the available slaves. Process is called as fault tolerance mechanism. So these are master node responsibilities. Slave node responsibilities are only two. Slave node responsibilities are only two. What are the slave node responsibility? One is storing data, second is processing data. Storing data, and second one is what? Processing data. How and who will decide how many slaves needed? So the number of data nodes depends upon your volume of your data. Who will decide means, see, how many data nodes required depends upon the volume of your data. How much data is coming daily? What is the volume of your data? Based on the volume of the data, your data nodes are going to get configured. we are okay. So if you want to go with 40 node cluster or 60 node cluster or 100 node cluster, it depends upon the volume of your data. If huge data, then you will go with more number of bigger cluster. So slave node responsibility, storing data and processing data. Okay, fine. Storing and processing data. So based on this, just I given an overview of this. Now based on this, let us extract the advantages, Hadoop advantages. First one, what is the first advantage of Hadoop? Unlimited data storage. Unlimited data storage. Unlimited data storage because of a feature. Here in Hadoop, we are going to see a feature called horizontally unlimited scalability. Horizontally unlimited scalability. What do you mean by horizontally unlimited scalability? Horizontally unlimited scalability means horizontally unlimited number of slaves can be added. Scalability means adding. Horizontally unlimited number of slaves can be added. For example, to explain this, I said Hadoop follows master slave architecture, single master and multiple slaves. Single master and multiple slaves, S1, S2, S3, S. So here, for example, horizontally unlimited scalability means horizontally unlimited number of slaves can be keep on adding. For example, if you're running a business, you are running a small business with only 10 slaves, think that, but your business has increased. Your business has increased means Your business has increased, means branches are increased, means customers are increased, means data is increased, means your number of slaves also need to be increased. If customers increased by if customers increased by 100 times and data increased by 1000 times, then you cannot go with the same number of slaves. Number of slaves need to be increased. You are going to add some 40 more slaves or 50 more slaves, means horizontally unlimited number of slaves can be added. Horizontally unlimited number of slaves can be added. Fine. Because of this feature, Hadoop is able to store unlimited data, horizontal unlimited scalability. That is one.
Excuse me.
Yes. Yeah.
I have a question. I'm not able to hear what other person is asking you the question. Is that normal or is there some issue?
Hey, anyone ask any query? I didn't get that.
No, if anyone asks you the question, I'm not able to hear exactly what he's asking you.
Oh, okay. 1 second. Okay. You are unable to hear. Okay, 1 second. I'll repeat that. I'll repeat the question and I'll just say that I hope it's in line. It's like a conference. Like everybody should hear that.
Yeah, yes, you're right.
Yeah. Everybody should be able to hear that question also. But someone they are typing. That's why I'm just going there to the chart panel. Even the chart panel also, everybody can see that question. How and who will decide that how many slaves needed? Okay, fine. Horizontally unlimited, so the sessions are interactive sessions. Everyone, you need to queue responses for whatever we discuss, and everything is practical oriented. There is no theoretical here. Okay, horizontally unlimited scalability. Okay, second is very high speed processing. Very high speed processing you are going to see in Hadoop because of parallel processing. Very high speed processing. Yeah, very high speed processing because of parallel processing, I'm saying. Okay, observe. If I discuss about parallel processing or non-parallel processing, let me give a labor example. What is the difference between non-parallel and parallel? Non-parallel and parallel. Non-parallel, for example, I'll give a labor example, like one person preparing one item taking 1 minute. The same one person preparing 10 items taking how much time? 10 minutes. The same one person preparing 100 items taking 100 minutes. So in this way, 1000 items, 1000 minutes. But in the case of parallel processing, 1 item 1 minute, 10 items 1 minute. So anything like yes. So here in the case of parallel processing, there I said persons, here we are saying it as system slaves. Here multiple slaves running parallel. So very high speed processing. Here even if volume is increasing, speed won't decrease in the case of Hadoop. So very high speed processing, that is one. I'll just give some examples related to this processing and storage, very high speed processing. And third advantage is Hadoop can handle all varieties of data, structured, semi-structured and unstructured data. Can handle all varieties of data. Next is like serious. Hadoop is an open source. Hadoop is an open source, no licensing required. Hadoop is an open source, no licensing required. Let me see, you can see a lot of cost cutting here. It's an advantage. And commodity hardware we say. Commodity hardware means Hadoop can run with any commodity hardware. It's not that high configuration is required, not like it can run with any configurations. Mainly see, Hadoop is meant for unlimited data storage, very high speed processing, can handle all varieties of data. Okay, fine. So these are the main advantages of Hadoop. And if I discuss about, see, 1 second, before I go with this, okay, Hadoop advantages, unlimited data storage, and very high speed processing. So I can give some examples as a lot of tests were performed on Hadoop. For example, if you see very high speed processing, Yahoo has conducted many tests. Yahoo has conducted tests on various databases. It has taken a table, Yahoo has taken a table of size 100 TB, consisting of 1024 columns, and the task is what? Sorting based on 16 columns. So what is the time taken by various databases? What is the time taken for the various databases for performing this task? First, this Oracle has taken nearly 3.5 days to process this. MySQL has taken nearly 6 days to process this. Teradata, a specialized database used for data warehouse purpose. Teradata, it can handle TBs of data. It has just taken 4.5 hours. Per. And Netija, it has just taken 3 hours for process it. Finally, Hadoop, it has just taken 3.4 minutes to process it. That is what the speed of Hadoop. Latest version of Hadoop has just taken 1.2 minutes to process it. That is what the speed of Hadoop as compared with other things. So meant for storage and meant for processing. Because of this storage, this is processing point of view. Storage point of view, for example, I'll come back to this. Yes, 1 second. So Hadoop follows a master and slave architecture, single master and multiple slaves. Hadoop advantages. And here if you see, why databases like Oracle cannot handle or store unlimited data? Means there is a limit on the number of slaves for databases. Oracle can go with a max of 256 slaves. MySQL can go with max of 54 slaves. MySQL Express can go with a max of 256 slaves in the real time. Even Oracle can go with multiple slaves up to 256 slaves. Limit on the number of slaves. There is a limit on the number of slaves. Any database can go up to 256 slaves. But Teradata, specialized databases like Teradata, Netija, Vertica can go with 512 slaves for storing its data. But currently Teradata, Netija going with 1024 CPUs supported. They can go with that. But even though 1024 slaves are CPUs means it's not like it's limited only, not unlimited. Once they get filled, they cannot store further data. But here none of the databases or specialized databases are able to accommodate huge data. But Hadoop, there is no limitations on the number of slaves. I said in Hadoop there is no limitation on the number of slaves. I said it can go with 1,000, 5,000, 10,000, 20,000 slaves. Yahoo when first time implemented Hadoop, it went with 4,000 slaves for storing its data. Currently, Yahoo going with 12,000 slaves for storing its data. Facebook, when first time implemented Hadoop, went with 8,000 slaves, 8,000 CPUs for storing its data. Now, currently, Facebook going with 36,000 slaves for storing its data. Okay, fine. So this is what Hadoop proven in the market, storage point of view, and just now I said processing point of view. Very less time you are going to see, 3.4 minutes. and unlimited number of slaves supported. Horizontally, you can keep on adding the slaves. There is no limit on the number of slaves as you see in other databases. That's why Hadoop has got a great boom in today's market. Fine. Hadoop has got a great boom. So if you see, wherever you see huge data, most of the times today, like huge data is getting generated, so Hadoop requirement is there a lot. So many projects are getting migrated to Hadoop environment from other things, especially like data warehouse kinds of projects. They are getting migrated to Hadoop environment. So there is a great requirement for Hadoop today. Fine. If I discuss that Hadoop ecosystem tools, what I'm going to discuss as part of this course. HDFS for storage point of view, MapReduce, Peak, High, all these are processing components. Scoop, NoSQL databases. One second. Okay. I'm going to discuss this following ecosystem tools: HDFS, MapReduce, Peak, Hive, Scoop. Scoop is for importing and export operations, for importing data from different databases to Hadoop and exporting data from Hadoop to the databases. And NoSQL, I'm going to discuss one NoSQL database like HBase, and two streaming components, see, Flume and Kafka streaming components. Yarn, yet another resource negotiator. See, Spark is a separate course. I'm not going to discuss as part of this, but just I'm going to use some information about Spark. Spark a separate course. So I'm handling separate course for that. Zookeeper. So totally 10 components I'm going to discuss: HDFS, MapReduce, Peak, Hive, Scoop, NoSQL, HBase, Yarn, Flume, Kafka, Zookeeper. That is what I'm going to discuss in depth. Totally in depth I'm going to discuss. It takes like 1.5 months. In brief, I'm going to discuss about this. It takes like 45 working days. Fine. From the scratch ground level to that advanced, I'm going to discuss on this. And Hadoop trends and job market. If you see, just now I said Hadoop has got great demand in today's market. See, size of Hadoop and big data market worldwide from 2017 to 2022, how it is going to be. 2017 it was 17 billion US dollars. It was 2018 it became 24.3. In 2019 it was 34. In 2020 it is 49, almost 50 it has reached. In 2021 it is expecting to 69, and in 2022 it is going to be 100. And see this Hadoop market from 2012 to right now. It's an increasing graph. You can see 2012, 13, 14 to 20. It's an increasing one. And see that salaries of Hadoop as compared with other technologies.